This is Module 6, and we'll be covering electrical boxes and getting more details of how we connect conduit to boxes. So device boxes are anything that can open up where you can see wiring, where you can use as a pull station or making connections. So first we're going to start with outlet boxes. In this Module 6, we're going to identify boxes and their applications. We're going to look at the different sizes of outlet boxes and install outlet boxes. And so we're going to go through a task in the lab where we're going to identify appropriate box types and size for a given application. The first thing is just different type of outlet boxes. And the first thing is that how we join conduit. The conduit is what's supporting the wiring, the conductors, but the boxes itself. And the boxes will have knockouts. And the knockouts are where you would put your box connectors. And so boxes must be properly selected for the application. For example, you can put a outdoor box on it. Well, let me reverse that. I guess you could if you really wanted to, but it'd look awkward. Wouldn't fit in the wall correctly. But you wouldn't put an outdoor box on the inside. But certainly you will never put a indoor box outdoors because it's not waterproof or watertight. And so we're going to choose the right box. And we're going to use the right box for, again, inside of a house. Looking at a ceiling fixture compared to a switch box or a box that's going to be used for an outlet, a receptacle, and the different type of things you're going to use. So there's some things that are interchangeable that you can use, but you maybe change out the mud ring to make it a single gang or two gang, or to find it larger boxes because you got multiple switches or receptacles. So boxes must be properly selected for the application and the size and installed correctly in order to minimize costs and ensure safety. And safety is always the main thing. All openings in the outlet boxes must be closed per the NEC section 314.17a. Again, what you see in the picture above, you see the knockout enclosures. These are used for to pop in if one of the knockouts is, you can't just leave it open for safety reasons. Somebody could stick their fingers inside of a box, it might be live wire, and it could get shocked. But it must always be closed, always. You just cannot leave it open. So if you see an electrician or a person call themselves electricians and they got knockouts missing and no plugs there, just assume that they not a true electrician, because electricians are fanatical about making things right. Here's another type of box that you will find. This is the design for a ceiling box. It's an octagon pull box, and it has a bracket that will be attached to the ceiling joists to be able to hang a light fixture. Now, they make different types. Again, making sure you are for the right application. If you have a ceiling fan, you have to use one that is heavy duty to be able to support that weight. Or if you have a large chandelier, it must have a special supports to support the weight. If it's just a small light fixture, it's a different story. That it don't have to be no heavy duty one. You don't want to put a heavy duty one in that case because you're just wasting money. So again, certain applications would determine what type of fixture box are you going to be using. So boxes are typically constructed of steel, cast iron, aluminum, brass, or non-metallic materials such as fiberglass or reinforced polyester. Boxes are designed for use in floors, walls, ceilings, and etc. Ceiling boxes must be attached to a structural member of the building and must be rated for the weight of the attached fixture. Again, ceiling fans and chandeliers. Octagon and round boxes. Octagon and round boxes are used for wall-mounted light fixtures. Um, again, it's for light fixtures. Extension rings, we call them mud rings, are used where necessary to add to the capacity or to bring the box flush to the finished surface. So again, it all depends on the type of box you're using, but some boxes will have extension rings. Another way they would do it is what we call the 1900 box. It's a box that is actually 4 inches by 4 inches square, and you can put mud rings on those. Nice thing about it, it's very versatile, and you can use it for different applications. Uh, because you could change the mud ring on it, that you can use it for switches, you can use it for outlets, and the mud rings is designed on the thickness of the drywall you're using. So 3/8, um, half inch, 5/8, and so forth. This is a non-metallic box and is used for a ceiling fixture. Well, it looks like a non-metallic box because of the color. It could be, I don't know, I'm just looking. It looks like it's non-metallic. We got a bracket to support it from the ceiling. Fixture hangers are used to support a fixture between two ceiling joists. Again, it would just be nailed to the ceiling joist to be able to support the weight of a light fixture. But again, this is a lightweight type of box to be supported. Octagon and round boxes. Some fixtures include a wiring termination space and can be used for shallow ceiling boxes. Yeah, they do make some like that. That is really thin. It's almost like a pancake. And you can cut right into the drywall and run your electrical to it. And it's thin. It's thin enough that um, it could the drywall basically because there's recess into the drywall. So again, of course, this is only for a light fixture that is hanging from a ceiling. So it's a shallow ceiling box. It's supported by a joist. So they put screws in it into that really shallow box. So the NEC requires that boxes have a minimum depth based on the size of that of the conductors, and of course we're looking at the weight of it. So again, that shallow box is the thickness of that drywall. Alrighty, this is a square box, a 1900 box, and look at that mud ring, how thick it is. So that looks thicker than 5/8. Could be 5/8 using metal studs too. But anyway, square boxes are available in various sizes and depths. Extension rings can be used um, to increase capacity. And so square boxes may be screwed, nailed directly to the structural members or attached using brackets. Okay, this one is going to a metal stud, so they got a bracket on the side and they got the screws to hold the box there. They certainly speed up the process, just popping the screws in to hold it there for you. Um, Again, we get this installed to keep it from moving uh, around in the box if you're pushing through. So square boxes may be, like I say, maybe screwed, nailed. Most of the time it's screwed in because everyone got screw guns these days. People are using less and less nails. Okay, device boxes, like for switch. Um, Device boxes are used for flush mount applications in residential and light commercial construction. Some boxes include um, integral nails for rapid installation. The plastic boxes are really nice for that because it comes with the nails already there, so you could just tap it. And of course, you would extend it out the opening to the depth of the drywall. These are some other boxes. This would be a metal box. This would we use most likely Romex. Here's with a non-metallic box with side brackets for mounting on the face of the wall stud. So this will go right to the wall stud. This one just nail right to the stud. So these are taken over applications of this one here with the nails already there. It just makes your job so much easier. This one has the bracket. And of course, this is the metal box. Now, masonry boxes are designed to go into concrete, and you bury it into concrete. And so masonry boxes are attached to the rebarb. Rebarb is structural metal that they would put into concrete to help with its tensile strength. And so attached to the rebar before the slab is poured. To avoid offsets, use a tall enough box so that the knockouts are located below the rebar. The boxes used in concrete or underground applications require the use of waterproof equipment. So again, this concrete box is, or the masonry box is definitely deep. Sizing outlet boxes. The maximum number of conductors permitted in the standard outlet box is listed in the NEC table 314.16a. Devices that add to box capacity include device covers and extension rings. So again, there's a certain amount of space inside of a box, but if you put extension rings or extensions on it, you can actually get more out of it. For example, you notice that this has an open back to it. This actually can screw onto another rectangular box and be able to get more capacity of inside of the box. When I say capacity, it's more wiring. Sizing outlet boxes. So in other words, deductions must be made for fixture studs, for hickeys, cable clamps, switches, receptacles, and conductors. Deductions must be made. So there's a certain number of wires a box can hold, but when you start putting things inside of it, like receptacles or switches and things like that, we have to start deducting the number of wires. So one conductor is deducted for each fitting. For each fitting. One conductor is deducted for up to 4 equipment ground conductors, bonding jumpers, or any grounding conductors over 4 are counted as a quarter of a volume conductor for each additional wire. 2 conductors are deducted for each yoke device, such as a receptacle or a switch. 2 conductors. So again, depending on the maximum, so we can go back to NEC 314 and look up, matter of fact, in the tables, you can go into and see where they list out the number of conductors based on the cubic inches inside of a box. Devices and components that require deductions in outlet box capacity. So we can see all these different things that we have to consider. So again, in section 314.16, we can go through and look at all these different things that we have: fittings, switches, outlets, different components, grounding wires. All can reduce the amount of capacity of a box. So if you need to pull a certain number of wires, you may have to add a box or figure out something, or look at a different way to be able to connect your components. So again, you could add more depth to it. Like 1900 boxes could hold a lot of wires, more wire than a handy box. But if you need more, you can put an extension on it, and that extension will increase your capacity of wires that you can use. So you can look at each one of these. For example, at the very top is that each fixtured stud or hickey counts as one conductor based on the largest conductor in the box, based on the largest conductor. So if you got a number 10 and a couple of number 12s and a couple of 14s, you're going to add up to certain things. But here again, switch counts as two conductors because it takes up a lot of space. The reciprocal counts as two conductors. It's a cable clamp. One or more cable clamps can count as one conductor. Using wire nuts and things like that. Since these conductors are spliced inside the box, they must be counted as four conductors. Again, let's look at that. Since these conductors are spliced inside of a box, they must be counted as four. So we got two coming in, two leaving. Two coming in, two leaving. We got the grounds too. Each conductor, where you see where you get the screw terminals, the black and white screw terminals, and it's right here. Is that each conductor originating outside of the box and terminating inside the box is rated as one conductor. Two are shown here, therefore a deduction of two conductors must be made. Let me just repeat that again. Each conductor originating outside of the box and the terminating inside the box is rated as one conductor. Two are shown here, therefore a deduction of two conductors must be made. Conductor running through a box counts as one conductor. Since there are two conductors shown here, these count as two conductors. Usually going to have two because you need a hot and a neutral. So again, to keep from overloading a box, which you will find time to time, to keep it from overloading, we need to look at the number of conductors that can fit inside of a box. Sizing outlet boxes again. Items disregarded when calculating box capacity, including grounding clips and screws, wire nuts, cable connectors, pre-wire fixtures, wire and pigtails. All these things are disregarded. Like a wire nut, even though it takes up space, wire nuts and crimp connectors need not to be counted in the volume calculation. The box connector terminating with only a lock nut on the inside of the box need not to be counted. It doesn't take up a lot of space. And you got to have it to be able to bring a wire through. Conductors, no part of which leaves the box are not counted. If it's coming in, so these grounding clips and grounding screws is not counted. The box connector, here's another box connector here. It's like for green fill. It's a 90-degree connector. To determine the size of an outlet box, count the number of conductors and equivalents, then determine the space required for each conductor using going to the table again, NEC table 314.16b, and multiply that by the equivalent number. Use NEC 314.16a to find the correct box size. So in other words, if you've got a certain number of conductors, and a lot of times you want to figure this out before you even put the box in, so you know you got the right size box. You don't want to use a handy box when you need a 1900 box. When installing boxes, the box must be correctly sized and listed for the application. Conductors must be protected against abrasion and the box supported properly. Boxes must remain accessible for future repair and maintenance. So we don't bury it into a wall, cover it with drywall, and expect that it's going to never be used. If somebody trying to pull wire and find out that there's a box where they can't pull the wires because it is a pull box in the wall that's not accessible, it would make it very difficult. They got to tear the wall open to find it. The requirements for receptacle locations in dwelling units are listed in NEC section 210.52 for receptacles located in dwellings units. Here's some requirements. This is really interesting, and maybe people may not even know this and be learning it now. Some of the most important things, especially today, so let's say residential. You should not have a reason. You should never have a reason to bring out an extension cord to plug things in, because there should be receptacles close enough that the power cord on that device should be able to reach. However, we do know in older houses that is not the case. So here's the rules, requirements for receptacle locations in a dwelling. Coming into a room, let's start at the bottom. Let's look at this. Listed baseboard heaters, including instructions that may not permit their application below the reciprocal outlet. Again, putting it above a baseboard heater, it can cause problems because the power cord can lay against it and burn it. Now, coming into a door, there should be at least an outlet within 6 feet of that door. Remember that, at least 6 feet. So coming through any door, walking through, you should be able to turn around, especially if it's newer construction. You should be able to have a receptacle within 6 feet. Within 6 feet. Here's some other rules. Now, a floor receptacle is required along fixed glass panels if the receptacle on the either side of the panel are more than 12 feet apart. Okay, so again, a floor receptacle is required along fixed glass panels if the receptacle on the either side of the panel are more than 12 feet. Remember that 12 feet. The 12 feet is important. So in other words, within 12 feet, we should have an outlet. Of course, coming through a door, you got to be within 6 feet, and then it's 12 feet. So if you're going through a room, you should be able to have at least outlet on every wall, and sometime 2 outlets. And if it's a large, you may find 3. So NEC section 210-.52A2 does not consider the sliding portion of a sliding door as wall space when determining the placement of receptacles. Here's the reason: because sliding doors goes all the way to the floor, and it's not a wall space, it's a door. So sliding doors are considered doors in construction, not windows, not windows. If it's a window, you should put one under a window. You should put one under the window if it falls within that 12 feet. So going back to the other one we just, on the left side, we just talked about, a floor receptacle is required along fixed glass panels if the receptacle on either side of the panel are more than 12 feet. So again, 12 feet. So you can measure that distance from one outlet, hit the wall, go across again. So again, it's not 12 feet apart, but if you, let's say it was 4 feet here, so this next one need to be at least 8 feet off this wall to be in code. Okay, so it's not every 12 feet. If this one here off this wall is 8, and if the room, this wall here, it has to be, let's say it's 14 feet, you would actually have another one there. So again, staging it out so don't have to have power cords. Here's mounting height, 12. It all depends on the person. Electricians, reciprocal mounting heights may vary to suit the building use and structure. So if you got a finished floor, the bottom of it about 15 inches off the floor is okay. Um, if it's a countertop, um, they said a faceplate should completely cover the wall opening and seat against the wall surface. It should never be split between ceramic tiles and drywall. You got to either be in on top of the ceramic tiles or on the plane. Um, if you got a split wall with ceramic tiles and drywall, but it should be level. The second thing is that it should be at a certain height. They have here 42 to 46 inches. Here's the reason why. A countertop will normally would be 35 inches from the floor. So again, this will be high enough off the floor to be able to plug in and not hidden by something on the countertop. So 42 inches. So again, 35. So this would be about 7 inches above the countertop, at least 7 inches. It could be taller, but about 7 inches. Oh, this is what I was explaining before. You shouldn't split a receptacle uh, between two different materials because it's not going to sit flush or it's going to look tacky. Because either you're going to have to cut out the ceramic towel to fit the thing in. So either it should be on the ceramic towel or above it if it's a split wall like this. Broken, jagged, or gapped wall spaces must be repaired prior to installing the reciprocal faceplate. So um, if you look at this, it's not really that bad. This cover may cover it, but the drywaller will definitely fill this in. Okay, and just to make sure that it's tight, a tight fit. So gaps or openings around the outlet box must not be greater than 1/8 of an inch, and if it is, it must be repaired. And that's found in section 314.21. Now, these are wire nuts, and wire nuts are color coded, well, at least most of the time. Usually red, yellow, blues. You may find some manufacturers just have one color. Well, they kind of change them up, but it's kind of there's some orange, and there's pretty standard colors. But like I say, some manufacturers change it. The blue ones you see there are very tiny ones for smaller gauge wire. So wire nuts are color coded for different wire sizes. They are also characterized by voltage ratings and application, such as copper to copper. They do make from aluminum to aluminum, which we don't use very often, but in some applications they will have it. Following the manufacturer's instructions when installing wire nuts. Usually, believe it or not, they say you should only use a wire nut just once. If you have to take it off, they want you to put a new one on because it may not sit right. So, again, follow the manufacturer's installation requirements. Making connections. These are wire strippers used to strip the insulation off the wires. Now, to keep in mind that you may have two different gauges on it. If you look at this picture, you see it says two different 22, 18, 16, 14, 12, 10. Really, they are trying to, if you're using stranded wire or solid wire, is a difference. Stranded wire are a little bit thicker because there's a lot of smaller wires wound together, which takes up a little bit more space. The solid wire are going to be smaller, so make sure you use the right size stripper for the type of wire you take an insulation off of. Because if you're using something too small for stranded wire, you can certainly cut into the wire and lose some of your capacity of your strands. So be sure to choose the correct tool for the size of wire being stripped and make a clean square cut. Insulation is typically stripped back about a half an inch, but may vary depending on the size of the wire and the type of wire nut in use. It takes practice to make sure you stripping it off. You don't want to take too much off because you may use a wire nut and might have still bare wires that are exposed, which you should not have. I see some guys that do it and they just wrap black tape around their wire nut. But I believe if you actually strip it correctly and make a good connection, you don't need electrical tape around every wire nut. Turn the wire nut until the conductor is fully seated in the wire nut. A complete insulation should provide a tight electrical connection between the conductors. Always tuck the conductor back into the box so that they are not protruding when the final wall finish is applied. Yes, try to push it back, especially if you're using some type of, you're cutting the drywall out for the box, the electrical boxes, that you don't want to damage the wires as you um, as you cutting the drywall. Alrighty, connector is the device used to physically connect conduit or cable to outlet box, cable, or cabinet rather, or other enclosure. Explosion proof. It designed and constructed to withstand an internal explosion without creating an internal explosion or fire, external explosion or fire. A handy box is a single gang um, outlet box used for surface mount to enclose receptacles or wall switches on concrete or concrete block construction of industrial or commercial buildings. Non-gameable which means the number of section of switches or outlets you're going to have. Also made for recessing mounted, also known as utility boxes. So a handy box is a utility box. It's a single game box and designed to only take one device. Outlet box is a metallic or non-metallic box installed in an electrical wiring system from which current is taken to supply some apparatus or device. So outlet boxes, again, there's many different types. We talked about a few of them. In the lab, you're going to look at multiple different boxes and to identify them. Rain tight. Rain tight is a type of box that is it can be outdoors. It's designed to be outdoors, where there could be moisture around it, like rain or snow. So rain tight constructed or protected so that the exposure of beating rain will not result in entrance of water under specific testing conditions. So rain tight is, again, it's used for outdoors. And a lot of times they have a gasket around the faceplate to the box to help seal out water. Watertight construction so that the moisture will not enter the enclosure under specific testing conditions. So rain tight and watertight is very similar. Matter of fact, rain tight, watertight, and waterproof is, matter of fact, a lot of people use it interchangeable, but they are different because rain tight, rain usually just drops straight down. And watertight, you may have a water hose spraying it. And of course, if it's just rain tight, if it can allow water to go through a different way, it will. But when it's watertight, it is sealed. I mean, everything is sealed. It will keep water from coming in. So it's constructed so that moisture will not enter the enclosure under specific testing conditions. So weatherproof, again, all these are similar, very similar. Constructed or protected so that exposure to weather will not interfere with the successful operation. Um, for example, if you got something outdoors, you got a switch on the wall to turn lights on outdoors, it should be weatherproof. It should be weatherproof because you're going to see rain, you're going to see snow, you're going to see all types of weather, hail, and so it should not interfere with its operation. A receptacle is a question. Receptacle is usually housed in an blank. Is a pull box, round box, junction box, device box. Hmm. It's device box. A pull box is used just for that purpose, to pull wire through, to make it easier to pull wire, or to make connections. A round box, again, or and is usually used for fixtures, light fixtures. Um, a junction box is a box that's used for joining wires or a smaller pull box. If a box can hold 8 number 12 conductors and contains a cable clamp, a switch, a looped conductor that is 13 inches long, and final number of number 12 conductors allowed in this box is what? Again, let's look at this, and we could go through your book. I'll give you the answer, but I want you to look it up. It says it can hold 8 number 12 wire, but it have a cable clamp. Is a cable clamp considered? Say a cable clamp. Okay. A switch. How many we have to deduct for a switch? A loop conductor that is 13 inches long. And the final number is what? It is 3. Can hold 8. So once we start counting these numbers, it will add up. So go through your book and see how we came up with 8. For example, we know that a switch considers 2. Okay, that's 2 right there. That brings it down to 6. And so we got, if this is 2, and we got a cable clamp, and we have a loop conductor, if you add them together and see what the total number come through. So check it in your book so you can memorize how to do deductions. A box installed in a wet location must be blank. Installed upside down, must be plastic, sealed with caulk, listed for the application. What's make the most sense is it should be designed and listed for that application. It can be plastic, but it may have holes in it. And so it can get water in it. So it must be listed, it must be designed for that purpose.